Okay, now I'm going to show you the no-load test. In my previous video, I showed you what are the characteristics of the practical transformer, and we got to this equivalent circuit, and I explained what are all of this. And now I'm going to explain you what is the no-load test. Now there are two tests to measure all of this and determine all of the values of these parameters over here. Now the no-load test looks like this. We have one phase supply, alternating current. It has to be an alternating current. We connect an ammeter here, a wattmeter, and in parallel here a voltmeter, and here we have a transformer like so. And this is the basic schematic for the no-load test for one-phase transformer, single-phase transformer. One side of the transformer is open. Open. There is no load, so we have an open circuit on one side. Usually, we do the no-load test on the side where the voltage is lower. And why do we do that? Because in this particular situation, we measure only the parameters that are for the this middle branch. Why? Because in an open circuit we don't have a current that is going to flow in the secondary now or in the primary. It also depends on which side do you measure this. Which side you measure this no-load test, and all the power, or the active power, because a wattmeter measures the active power, goes on the core losses of the magnetic circuit. Of course, you have a winding resistance over here, but that is neglected. So, in no-load test, we calculate the value of the exciting current, we'll calculate what is the core loss resistance, and we calculate what is the reactance. Now, if we calculate it from the primary side, if it is a open circuit, then this branch, right branch, doesn't exist because we have an open circuit, and then the current is not going to flow in this direction. So in an open circuit we don't have this right branch. Now one more stuff to say. If or not if the voltage V1, the supply voltage, is almost the same as the induced voltage on the winding on this circuit. So this R1 and XL and reactance XL1 are neglected. So this, now we have an equivalent circuit for the no-load test from the primary side is like this. We have the supplied voltage, and that is going to be the induced voltage on the primary side of the transformer, and we have the resistance R index C1, and we have the reactance of magnetizing the core Xm1. Now the current in this circuit is only going to be the exciting current, so that is going to be IF1. Now we measure this with an ammeter, ammeter, and we from this test, from this no-load test, we can measure the exciting current. Now, in this branch we have IC1, and in this branch we have IM1. Okay, now what can we do next? This wattmeter is calculating the losses, the core losses of the active core losses in the winding or in the magnetizing of the transformer. So this wattmeter is referred to RC1. I have to say that R1 and this here is neglected because these values are very small. How do we calculate the this resistance of the core loss? Well, we know that the power on a resistor or on a consumer or an impedance, but in this situation it's like a resistor. You can look this as a resistor that is equal to the voltage on it divided by its resistance. Now then you can easily see that the resistance of this the core loss is equal to the voltage V1. You can see you have V1 or E1 from here to here, but it's on the same potential from here to here. So you get that RC1 is equal to the supplied voltage on squared divided by the measuring of this wattmeter. Now you calculated what is the resistance of the core loss. How can you calculate the current? By Ohm's law, IC1 is equal to the voltage from here to here is V1 divided by RC1. And you calculate RC1. And how can you measure the current IM1? Well, you know that for the exciting current, IS is in phase with the induced voltage, and IM is 90 degrees shifted from it, and then the exciting current looks something like this. Now, this is the hypotenuse of the Pythagoras triangle, and with Pythagoras theorem, we get that IM is equal to square root of the exciting current squared minus the IC squared, all that on all the half. So this is the square root of this, and this is the Pythagoras theorem. And this is the value that we calculate. This is how we calculate the magnetizing current over here. And how do we calculate the magnetizing reactance? And we do that by this formula: Xm is equal to the voltage on it, which is equal to V1 divided by the current passing through this xm1, and that is im1. So we calculate xm, we calculate rc, and these are the parameters from the primary side. Okay, and if you want to transfer this to the secondary side, you just divide this with a squared, and the current you just divide it by a. So thank you, and see you in my next video. I'm going to show you the short circuit test. See you in my next video.